Alright, so we left off with a simple game. Well, I guess to call it a game would be a little bit of an exaggeration, but we can look and we can see the single button of a sequence puzzle. It's not currently interactive at all, so let's, as our next step, let's make this interactive. So first thing I want to do is make a player controller, and I'll just do that in blueprints. And this player controller will be responsible for making sure that I can move my mouse around and click on things. So we'll show the mouse cursor and enable click events. That's good. Um, in order to uh, make this player controller be used, I will also make my own game mode. You might recall looking at the C++ that we had a game mode base that was generated for us as part of the project template. I'll make a new blueprint based on that called BP game mode. And in this game mode we can say we're going to use that player controller we just created. Good. And then of course we have to tell Unreal to use that game mode. And we'll set the map here, and that looks good. So now if we look at this, we can see our mouse, and clicking around doesn't do anything yet. So let's go into the sequence puzzle button and just make sure we're getting those click events. We can do something like event on actor, sorry, on click, here it is, on actor clicked, just print. Good. And ooh, here's an interesting problem that I didn't catch before. See, I've got this default pawn being created because the default game mode by default creates this pawn. We don't actually want that pawn there. So let's go over to the game mode, and we can override, let's see, over here in functions, we can override spawn default pawn for, and just make this return nothing. And that way, when we run this, yeah, there's no pawn. All right, good. And the click events are working. Great. Okay, so I think the obvious next step is to give some kind of a color to that button. So in my mind, the fact that the buttons have colors is part of their core model. So I'm going to do that in C++. So let's go to our button and say, this has a field. We'll make it a protected field, again, which means that it's accessible to this class and its subclasses. And this will be another U property. Blueprints can only read it. And we can say this is a F linear color. We'll just call it color. So linear color is a handy class to represent a color in RGBA. And F, the prefix F, tells me that this is a struct. If you've done some C and C++, you're familiar with structs. If you come from more of a Java background, a struct is like a class that only has public fields, you know, roughly speaking. Okay, so obviously giving it this data doesn't actually integrate it with the UI. So let's go back to where this is spawned, and we have a, yeah, I might have added that offline. So we're holding on to the actor that's spawned in this pointer to a button. And all I need to do here with the button is set its color, whoops, to F linear color. Oops, let's go with a nice red. Okay, so right after we spawn the actor, we set the color of that button to red. That looks okay. Go ahead and send that to the compiler. Meanwhile, obviously setting some field to red doesn't make it red, but over in blueprints we can do something about that. So remember we have this plane, and that's the plane that we want to be able to give it a particular material that will have the color that we want. So, whoops, compiler error. Let's see what I messed up. Oh, cannot access protected member. Of course. Right. If this is protected, then I cannot see it from another class. So we'll just make it public. That should be fine. And compile that again. Okay, where were we? looking here, we want to set a material onto this that is colorable. So let me make a colorable material. I think that's a good place to start. I'll make a material and I'll call it colorable. And so the idea here is I'm going to give this a parameter, which will be a vector, and that parameter will be a color. So we'll call this color. Whoops, what did I miss here? Here we are. And let's just take that and put it in the emissive for now. So here's a material that takes a parameter that should just make it that color. The default value here of the parameter is black, but that's fine. So when we create the button, what we can do is create a material based on the colorable, and we want to set that material to be the planes material. So let's see. Here is the plane. Oops. So if we have the plane, we can set material to be that material. And we also want to set this material's parameter. So we can say, probably easiest to do it this way. Set parameter, it's a vector parameter, and its value is get color. Now see that we can access this color variable that we set over here in the code because this is a U property and it's blueprint read only. So that's that color, and the parameter name is color. Good. Let's run that. Okay. So we haven't seen any color change, but that doesn't actually mean that we have a problem. Well, I mean, obviously there's some problem, but let me explain what's going on here. And in fact, this cost me a lot of trouble when I was building my sample version of this tutorial. Over here in the code, what's likely happening is that begin play is being called right as soon as we spawn, and then we're setting the color, right? But that means that at the point where begin play is called, the color is black, right? It's nothing, and so nothing's happening here. So we can try to validate that assumption by let's just go into the code. Oops. Let's go to the code and just comment that out for a moment. Go over here and say that this is a constant. It's going to always be red. Right, so now this is being, as soon as it's declared, it's being initialized to that color. And so this is really just a experimental code to validate whether or not I'm understanding what that problem is. Okay, I had a little glitch there. I'm not entirely sure what it was. But yes, we were able to validate what the problem was. So in the code, if I set this color to be red at the time that this field is created, and then I use blueprints to create a dynamic material instance and set that parameter to be the color, then I can see that the color is red. But what I really want to be able to do is set the color not here, but at the point where it's spawned. And why do I want that? Well, I want that because I need to be able to generate 4 different colors at some point, right? So maybe I'm over-engineering it right now, but it's a serious issue, and I want to show you how to overcome that because, like I said, this caused me a lot of trouble when I first ran into it. I had to learn a bit more about how the spawn sequence works. Let's just validate here. Yep, so we have the wrong color there. Great. So back over in C++, our solution strategy here is to use what's called a deferred spawn. And what that lets us do is start the spawning process, configure some variables, and then finish the spawning process. So in order to do that, we have to use a different way of spawning the actor. So it'll look like this. We use the uGameplayStatics class. It has a method called begin deferred actor spawn from class. We have to tell this who the owner is. The owner is the current class. We also have to tell it what class we're creating. and then we have to give it the transform again. So once again, I'll use the current actor's transform. So what this will do is give us back the object that is being created with the deferred spawn, and so we're going to call that the sequence puzzle button. Yeah, button is fine. Now, this class returns an actor. We're going to have to cast that into a sequence puzzle button, but we can do that easy enough with this cast. Oops, sequence puzzle button, and that should do it. Gameplay statics we have to import, and that is in a library called Kismet gameplay statics. All right, so this starts the spawning process, but it doesn't call begin play yet. So at this point, we can set this variable, and in this case, that's all of the initialization that we need to do. So we can go back to gameplay statics. Whoops. And we can tell it that we want to finish spawning that actor. And this actor is button, and we have to give it the transform again, which should be fine. It's not going to change in between. And so that, I think, should do the trick. Let's go and compile that. Right, so the sort of the moral of the story is if you need to send configuration data to an object or an actor that you're spawning in C++ code, then it's a good idea to use this deferred spawn option. Sure enough, there it is, nice and red. Great. So I can click on it, and I still get those click events. That's nice. As long as we're in here, let's go ahead and make this glow when we click on it. I think that'll be a nice thing to do before we wrap up this section. So I think I can do that just all with blueprints here. I'm going to go back to this colorable, and I'm going to give it another parameter, which I'll call, parameter. This will be a scalar parameter that I'll call highlight. And highlight will go just from 0 to 1. It's really a Boolean. I'm just going to say either it's highlighted or it's not. So I can use a nice trick here to make this work. Let's put in an if. So the question is my highlight greater than 0? Right, the default value for B will be 0. If I'm highlighting, then I'm going to use a constant value of maybe 8. And otherwise, I'm going to use a constant value of 1. Oops. And what I can do then is multiply my color by that scalar. I don't like the way that looks. Let's just break these. And, whoops. Take this one over here. Take this one over here. And put that into the emissive. So if it's not highlighted, then we should see just a plain color. If it is highlighted, we should see that kicked up by a factor of 8. So let's see, we can go ahead and save that. Whoops. Save it. Yep. And if we, oh, in fact, it was still running. That looks okay. Let's change the default value of this highlight parameter to 1. Save it. And look at it again. Yeah, there he is, a highlighted red. Kind of a funny orange color. But that shows that my material is set up correctly, so I'll take this back to its default value of 0. And then over in the puzzle button, we can, I don't really care about this anymore. Alright, what we need here is to take the onClicked and the corresponding onReleased, and then we can say when we click on this, we'll set that parameter to 1, the highlight parameter. But right now I don't actually have a reference to that material, so let's add a local variable here which will be the, whoops, call it material, and this will be my dynamic material instance. Oh, material instance dynamic, that's it. And this can be a private variable, and so when the material is created, we can set that over here. That's the, whoops, that's the material. Good, so now we have a reference to that material. We can get that material, and we can set the parameter on it. Set parameter, scalar, highlight we called it. So when we click, we set that to 1, and when we release, oops, when we release on the same material, we set highlight to 0. All right, compile that, run it. Nice. So we're still maybe several steps away from having a working sequence puzzle, but at least now we have a button that we can click. Not too bad. Next time we'll build on this.